Okay, let's unpack this. When you think about finding really old human history, especially somewhere like South Africa, um, the picture that often comes up is archaeologists, digging in caves.
Yeah, or rock shelters.
A-
Absolutely.
And look, there's a great reason for that, right?
Oh, definitely. These places are like natural time capsules.
Defined areas, amazing preservation sometimes.
And the sediments build up layer by layer. You get this beautiful stacked history.
It's given some incredible finds, key insights into past human behavior.
Exactly. Especially for understanding what we often call behaviorally modern humans. Things are just preserved so well in caves.
But if we only look in caves, well, it feels like we might be missing a big part of the picture, doesn't it?
A huge part. What happened out in the open landscape?
Yeah. And that's the real challenge. How do you find and understand that history at open-air sites?
They're much more common globally, but they're tough.
Erosion scatters everything. You don't have those neat layers. It's hard to know where to even start looking for something intact under the surface.
It's a fundamental issue in archaeology. Erosion can actually reveal amazing things on the surface, like clusters of tools.
Wow.
But in doing that, it destroys their original context. You lose the wear in time.
And the flip side is areas where sediment has built up nicely, potentially preserving context.
Often have nothing visible on the surface, so you're digging blind. It's a real paradox.
Okay, but here's where it gets really interesting. We're looking at sources today, a research paper from geoarchaeology and a related press release that dive right into tackling this exact problem.
Yeah, they showcase a really clever strategy using geophysics.
At this incredibly important open-air site in South Africa called Klein Hoek 1, KH1.
KH1, yeah. It's in the Doring River catchment. And it's special because it has this massive collection of artifacts just on the surface.
Including one of the most significant groups of still bay bifacial points found anywhere in southern Africa.
That's right. Beautifully made tools.
And the still bay period, that's what, around 75 to 70,000 years ago? Absolutely crucial for understanding those early complex human behaviors.
Exactly. And the site is huge, over 19,000 square meters.
Wow.
They found over 6,700 stone tools just lying there, both still bay, that's Middle Stone Age, and also later Stone Age stuff.
And the still bay finds specifically over 100 of those distinctive bifacial points.
Yep. And hundreds of the tiny flakes from making them, mostly this blue-gray quartzite. The paper has some great pictures of them, and I think they even found engraved ochre there before.
So KH1 really shows that paradox you mentioned.
Perfectly. You've got this amazing cluster of still bay points literally eroding out of the ground on one side of the site.
The western side.
Yeah. And amazingly, they're still quite tightly clustered considering the erosion.
So erosion exposed them, which is great.
But it wiped out the fine-grained context. How exactly were people using that spot? We lose that.
Right. You see the what, but lose the precise where and how. And meanwhile, on the eastern side, where it's less eroded,
and sediment seems thicker, there's basically nothing to see on the surface.
so you need to know how deep those buried layers go.
Right.
And if there are specific spots within them that might hold intact archaeology.
Exactly. You can't just dig trenches everywhere hoping to hit something.
Which brings us to the mission for this deep dive. How researchers use two specific geophysical techniques. Electrical resistivity tomography
ERT? Yeah.
and magnetometry to basically look underground at KH1 without digging.
The goal was to map those hidden layers and try to pinpoint promising spots for future, more targeted work.
So the challenge at these open-air sites is the exposure, the scattering.
Right. Sediment does build up, sometimes quite deeply, but unless erosion gives you a clue, you're lost about where to focus.
You need to know how thick those buried sediments are and where the potential hot spots might be.
Precisely. And that's where geophysical methods are so powerful.
Because they're non-invasive.
Non-invasive, relatively quick and cost-effective compared to digging large areas. They're standard practice in Europe and North America.
And used in South Africa, too, though maybe less commonly in the past.
Yeah, the sources mentioned some previous examples using ground-penetrating radar, GPR, and also ERT at places like Eland's Bay Cave, Amanzi Springs, even another site in the Doring River, Utsbankral 7.
So basic idea is measuring physical properties of the Earth.
Exactly, to create maps or pictures of what's hidden underneath.
Okay, let's get into the tech they used at KH1.
Yeah.
First, ERT, electrical resistivity tomography. How does that work?
Think of it like giving the ground a small electrical checkup.
Okay.
You stick metal rods, electrodes, into the ground, push a small controlled electric current between some of them,
Uh-huh.
and then measure the voltage, the electrical potential difference between other electrodes. This tells you how much the ground resists the flow of that current.
And different materials resist differently.
Exactly. Dry sand resists a lot, wet clay, not so much. Solid bedrock is usually very resistive compared to sediment.
So by measuring these differences along a line, you can map out the layers.
Precisely. You can build up a 2D picture, a cross-section, showing the different geological units, the stratigraphy.
Yeah.
It helps you understand how the site formed.
Does it find artifacts?
Not usually directly, but it maps the layers where artifacts are likely to be buried. It gives you that vertical context, the depth.
And at KH1, how did they set it up?
They laid out 3 long lines, mostly north-south. They used a 1-meter spacing between the electrodes.
Okay.
And a roll-along method, moving the electrodes down the line to make the lines really long, up to nearly 200 meters.
And how deep could they see?
Pretty deep, up to about 15 meters in some areas. They also used 2 different electrode arrangements, or arrays.
Why two?
One array, winner, is good for seeing vertical changes, like distinct layers. The other, dipole-dipole, is better for horizontal variations near the surface. Using both gives a more robust picture.
Got it. Different tools for different jobs. Okay, what about magnetometry? Using a gradiometer, how does magnetism find archaeological stuff?
Well, most soils have tiny amounts of iron minerals that are weakly magnetic. But human activities, especially building fires, can change that. The heat transforms those weakly magnetic minerals into much more strongly magnetic forms, like tiny baked magnets in the soil.
Ah, so a hearth leaves a magnetic signature.
Exactly, a localized magnetic anomaly. Also, decomposing organic stuff or even just soil disturbances and bacterial action can slightly enhance magnetism too.
And the gradiometer is the tool to find these.
Yes, it's particularly good for archaeology. It typically has 2 sensors, one above the other.
Okay.
It measures the difference in the magnetic field between those 2 sensors. This makes it really sensitive to small, shallow magnetic features like hearths, while canceling out the bigger, deeper geological magnetism or daily fluctuations in the Earth's field.
So you walk it across the site in a grid.
Yep, usually in a zigzag pattern, taking readings constantly, and you build up a magnetic map showing these tiny variations. Strong anomalies usually mean buried metal, which you also need to identify.
And how do they apply this at KH1?
They surveyed a big area, almost a hectare, covered most of the site, but deliberately avoided the main area where the still bay points were eroding out because they knew there was surface metal contamination there.
Makes sense.
But they made sure it overlapped with the ERT lines.
Right, so you compare the data.
Exactly. They processed the data to create these magnetic gradient maps, highlighting both the strong metal signals and the much more subtle variations they were looking for.
And those subtle variations are the potential archaeology. Because the paper mentioned evidence of burning associated with the artifacts.
Precisely. That known link between burning and the human occupation at the site makes finding those subtle magnetic burning anomalies a really key target for finding more intact material underground.
Okay, so they've done the surveys. What did the tech actually reveal? Let's start with the ERT. What did those electro cross-sections show?
The ERT worked really well. It clearly mapped out 4 different subsurface units based on their electrical resistivity.
Okay, walk us through them. Unit I.
Unit I is the stuff right at the top. Very high resistivity, meaning loose, dry sediment. It's the modern, wind-blown sand.
How thick was it?
Thin on the eroded western side, where the points are maybe a meter max, but thicker, over 2 meters, on the less eroded eastern side outside the fence, matches the loose dune sand you can see.
Makes sense. Unit 2.
Unit 2 is the crucial one archaeologically. It showed very low resistivity.
Meaning it holds moisture better, clay or silt.
Yeah, suggesting finer sediments, even though it's described as sort of hardened, semi-consolidated sand. This unit is thick, 6 to 8 meters deep in places, and crucially, the sources say this is the unit associated with those still bay points.
Ah, so Unit 2 is the layer those tools originally came from.
Seems so. Then Unit 3 was more localized, near the river channel on the northern side. Moderate to high resistivity, they interpret that as river gravels and cobbles, basically an old river deposit, a point bar.
Okay, distinct feature. How deep?
Up to 7 meters deep, but only about 13 meters wide. Doesn't stretch across the whole site.
Got it. And Unit 4?
Unit 4 is the bottom layer they mapped. Very, very high resistivity. That's interpreted as the underlying bedrock siltstone.
Okay, the base layer.
Yeah, its surface looks pretty uneven, probably shaped by the ancient river. They also saw some high resistivity lumps sticking up from it in one area. Could be bumps in the bedrock itself, or maybe big fallen rocks buried down there.
So, connecting this back to the archaeology, what does this layered picture tell us about KH1?
It confirms that Unit 2, the still bay layer, isn't just a thin surface scatter. It's a really substantial deposit. It goes down 8 meters right where the points are eroding.
Wow.
And potentially even deeper, maybe 10 meters below the surface over on the eastern side where nothing is visible.
So the potential for buried archaeology in Unit 2 is huge and deep across a large area.
Exactly. It really highlights the challenge. The layer is there, it's extensive, but finding specific activity areas within it is tough.
And the fact that Unit 2 is thinner, where the points are visible.
Supports the idea that the surface cluster is a lag deposit. The points got concentrated there as the finer sediments of Unit 2 washed or blew away over time.
That makes sense. Any other ERT features?
They noted some smaller, sort of circular, high-resistivity spots near the surface, probably just natural variations in sediment or moisture, not big features. And the southern end showed variable resistivity matching the visible scree slope from the cliffs.
Okay, so ERT maps the big picture, the layers, the vertical dimension. What about the magnetometry? What did those magnetic maps show?
The magnetic survey picked up two main kinds of signals, really strong ones, high-magnitude anomalies, and then the much fainter, low-magnitude ones.
The strong ones were?
Mostly modern metal, big signals lined up with the permanent survey pegs. Another line of signals matched the old fence line buried wire.
Right.
And then other scattered strong signals on the eroded western side were likely just random bits of modern metal trash near the surface. Interestingly, much less of that on the eastern side.
Okay, filter out the modern junk. What about the subtle anomalies, the low magnitude ones?
Ugh. Those are the exciting ones. They found these subtle magnetic wiggles scattered across the western side of the survey area, the same general area where Unit 2 is present and the still bay stuff is found.
But not on the eastern side.
Largely absent on the eastern side, yes.
And the interpretation is?
Based on their small size, their low magnetic strength, their location within Unit 2 territory, and that known link between fire and human occupation at the site. These subtle anomalies are interpreted as potential hearths or other small burning features.
So the magnetometry is basically pointing fingers at specific spots within that huge Unit 2 layer saying, hey, someone might have built a fire here 70,000 years ago.
That's the strong implication, yes. These spots represent areas of high archaeological potential.
And the fact they're on the west side where the known archaeology is, but not the east side.
Really strengthens the interpretation. It highlights how the magnetometry can target promising areas even when there's no surface clue right there. It contrasts the active west with the quiet east, magnetically speaking.
Okay, let's synthesize this. How does putting ENT and magnetometry together solve that open-air site paradox at KH1?
It gives you this powerful, layered approach. The ERT provides the essential framework, the vertical context.
It maps Unit 2, shows you how deep it is, how thick, where it extends.
Exactly. It tells you where the potentially artifact-bearing layer is located in 3D space underground, even if you can't see it.
But it doesn't pinpoint activity areas within that layer.
Right. That's where the magnetometry comes in. It provides the horizontal targeting.
Finding those subtle magnetic anomalies, the potential hearths.
Yes. Identifying specific spots within that vast Unit 2 that show likely signs of past human activity, specifically burning. These anomalies correlate spatially with Unit 2 and the known surface finds.
So you use the magnetic map to pick your spot horizontally. A cluster of potential hearths here. And then you use the ERT profile for that exact spot to know how deep you need to dig to get into Unit 2 there.
Precisely. You know where to dig horizontally and how deep to go vertically to hit the target layer associated with those magnetic signals.
It guides excavation in a much more focused way.
Exactly. It moves you away from random test pits or just digging where erosion happened to expose something. It lets you target areas with high potential and understand their stratigraphic context beforehand. Much more efficient, much less destructive.
It's a really compelling demonstration of how combining these methods can unlock secrets at these challenging sites.
It really is. And the applications go beyond KH1.
You think this approach could be used more widely?
Absolutely, especially in South Africa, where there are so many important open-air Middle Stone Age sites, it helps us get a fuller picture of how people use the entire landscape, not just the caves and shelters that happen to preserve things well.
It helps overcome a bias in the record, really.
It does. It lets us potentially find evidence of human life hidden right under our feet in places we might otherwise overlook.
Which leads to a final thought, maybe for you listening. How does knowing we can use tech like this to see ancient campfires buried meters deep, to map hidden landscapes, how does that change your perspective on the scale of human history?
Yeah, think about how much of the human story might still be out there, just beneath the surface in ordinary-looking fields or river valleys, completely invisible until we use these kinds of tools to look. How much bigger was the human world 70,000 years ago than just the caves we focused on?